So we're basically putting all our skills together. Remember, I'm going to sound like a broken record, that our long-term goal is, if we're given a quadratic trinomial in standard form, ax squared plus bx plus c is equal to 0. We're trying to find the x values, usually 2. Usually all the two x values that satisfy ax squared plus bx plus c is equal to 0. So if you need a visual representation of what we're looking for, is remember that ax squared plus bx plus c is in the shape of what's called a parabola, this U-shaped graph. So if the parabola is U-shaped, it can cross the x-axis, right, this y equals 0 line, in two ways. I just drew this diagram right here. So you're looking for x1 comma 0 and x2 comma 0. What two x values make that whole thing explode and become y equals 0? So what we've been doing all along is method number 1. I like to think of it like in video game analogies. Like if you have a beat 'em up video game, you have a quick attack, whether it's like a small punch or something that only does a little bit of damage, but it's effective on small enemies. But if you're getting overwhelmed, sorry, I want to repeat that. If your first move should always be to factor and zero product principal because it's faster. But there are some problems where factoring will take forever and it will, quite frankly, overwhelm you. Or, it's not even possible to do. So without further ado, the quadratic formula is what's considered your strong attack. So I like to think of it as the end-all, be-all. Does this have an answer or not? Where do I find these two x-intercepts for a quadratic function? The quadratic formula wipes out the entire screen of enemies in this analogy. Okay, so it's the strong attack. It takes forever to do, but it's worth it. Okay, once again, you pick the method that works best for you for the problem. And I've seen entire tests done with just the quadratic formula. I'm like, you do you, man. All right, so for instance, let's say we look at these problems by factoring. Again, we're going to do these three problems by factoring, and then we're going to do these three problems with the quadratic formula. So remember, x squared plus 8x plus 15 is equal to 0. So I like to factor, especially since a is equal to 1. That means I just need to figure out the winning team of what multiplies to 15 and adds to 8. All right, if you need this time to do the table, pause the screen. Well, okay, here we go. That winning combination is positive 3 and positive 5, because 3 times 5 is 15 and 3 plus 5 is 8. So what that does now is this factors into x plus 3 times x plus 5 is equal to 0. Hey, I got a multiplication problem. I like a multiplication problem, especially when the output is equal to 0, because that means I can use the zero product principle. I hit myself in the thigh. So x plus 3 times x plus 5 is equal to 0. It's a multiplication problem. I have to account for both cases that make y equal to 0. So I say x plus 3 is equal to 0, or x plus 5 is equal to 0. I solve both simultaneously, subtract 3 from both sides on the left side. One of the solutions is x is equal to negative 3. I look at the other equation, x plus 5 is equal to 0. I'm going to subtract 5 from both sides and get me x is equal to negative 5. So the two solutions for this quadratic trinomial, if you plug in x equals negative 3 into x squared plus 8x plus 15, you'll get an output of 0. That'd be negative 3 squared plus 8 times negative 3 plus 15. That'd be positive 9 plus negative 24, so that's 9 minus 24, that'd be negative 15, plus 15 is equal to 0. Plug in x equals negative 5, that'd be negative 5 quantity squared, plus 8 times negative 5 plus 15. That'd be positive 25 plus negative 40. So 25 minus 40 plus 15. That'd be negative 15 plus 15. That'd be 0. Two ways of getting y is equal to 0. Okay, so then x is equal, let's look at problem number 2. X squared plus 10x plus 25. How do I factor this? Well, I'm looking for the combination that multiplies to 25 and adds to 10. What two numbers multiply to positive 25 and add to positive 10? Well, that combination needs to be positive 5 and positive 5. So therefore, we can rewrite this. Sorry, the lights went down. So that means x plus 5 times x plus 5 is equal to 0. And then I can just break this down and go, hey, wait a minute. Do I need to split this up into two cases? No. It's technically only one factor, x plus 5. So there's going to be one solution. Specifically, x plus 5 is equal to 0. Therefore, x has to be equal to -5. And that's the only one. Now let's take a look at problem number 3. I'm going to roll this over here. X squared plus 4x plus 10 is equal to 0. Okay, now we're in business. A is equal to 1. Okay, thank goodness. So I need to figure out what two numbers multiply to positive 10 and add to positive 4. Well, spoiler alert, I'm going to try all the possible whole number suspects. 1 times 10 is 10. 1 plus 10 is 11. Okay, that didn't work. 2 times 5 is 10. 2 plus 5 is 7. I don't think it's divisible by 3 without being a decimal, and 4, and so on and so forth. I've run out of numbers is what I'm trying to tell you. Run out of whole numbers, rather. So for now, my answer is I don't know. Okay, for now. For now, my answer is I don't know. The answer is not I don't know, because that would get you 0 points. But we're going to show you why is the quadratic formula so useful. So without further ado, I'm going to put this on the side, and let's do some quadratic formula talk. So I shared with you on Google Doc. This was page 1. I find it much easier to look at this and read the text, and we're gonna draw on the case 1, case 2, case 3 part. So what does the quadratic formula do? The quadratic formula helps solve for the x-intercepts of a quadratic function. In other words, let's say you have a graph y equals ax squared plus bx plus c. If we set y equal to 0, we try to solve for x. Ax squared plus bx plus c is equal to 0. We can use what's called the quadratic formula, which basically looks like somebody sneezed the alphabet, but I assure you, I don't want you to memorize it. I just want you to know how to do it. Okay? So the quadratic formula states, hey, you can find these up to 2x values by plugging in negative b plus or minus the square root of b squared minus 4ac, all that over 2a. I know it seems like there could be multiple answers to this, but in this question, what looks weird to you in the quadratic formula? This whole thing, what looks weird to you? Well, for one, I've never seen a plus or minus sign, like, I've never seen that, plus or minus, like plus on top of a minus. But that's to show that this is two formulas at once. Negative b plus the square root of b squared minus 4ac over 2a, negative b minus the square root of b squared minus 4ac over 2a. But the truth is, I'm not that overwhelmed by it. But in particular, I'm here to point out that I'm going to highlight this in green pen, circle this. Turns out that the b squared minus 4ac is the most important part of the quadratic formula, because b squared minus 4ac is called the discriminant. Get your jokes out of the way right now. Math is racist, blah, 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 blah. Discrimination. I didn't sign up for this class to be discriminated against. I've heard them all, okay? It doesn't change the fact that it's called the discriminant, which means, if you want to know the definition of discriminate, it means to single out based on a case, okay? So now that we got the elephant out of the room, or acknowledge the elephant in the room, b squared minus 4ac is called the discriminant. So what's so important about b squared minus 4ac? The b squared minus 4ac tells you how many solutions there are. I will repeat that. The discriminant tells you how many x-intercepts there are. So let me put it to you this way. If the b squared minus 4ac is a positive number, so in other words, the number inside of the square root is positive, well, that means that there is a positive square root and a negative square root. So let me say, for example, let's take a simple square root like 9. The square root of 9 is 3, but I could also make the argument that the square root is negative 3, because 3 squared is 9. Negative 3 squared is negative 3 times negative 3. That's also 9. So technically, when you take the square root of something, you're looking for what number times itself is the inside. So if the b squared minus 4ac is positive, that means that I can draw, sorry, I just messed up right there. I can draw a quadratic trinomial, the parabola, and it's going to have two solutions. So if the number inside of the radical is positive, that means that it crosses the x-axis twice. Now, not all parabolas are happy face parabolas. Some of them are sad face. I'll just draw it like this. It can be an upside down parabola, and it will still cross 2 times. So in other words, what does this mean? If the b squared minus 4ac is positive, that means that there are 2 real x-intercepts. Okay. 2 real x-intercepts because of the discriminant being positive. Okay? If b squared minus 4ac is 0, so if that number inside of the square root is 0, well, let's take the square root of 0. What number times itself is 0? It's just 0. There's only one square root of 0, and it's 0. So therefore, there's no such thing as a positive 0 and a negative 0 yet. Just take calculus. It'll blow your mind. But for now, in the world of algebra, in the real life, well, not to say that calculus isn't real life, but for now, there's only one square root of 0, and that's 0. So if that number inside of the square root is 0, that means that you draw a parabola. I could draw a happy face parabola, but since there's only one square root, that means that there's only one x-intercept. So it touches the x-intercept, sorry, it touches the x-axis at one point. So now, or I could draw it the other way, happy face parabola, sad face parabola. That means that there's only one, sorry about that, holding real, sorry, let me write this down. Let me just put this really quick. There we go. So if the discriminant is 0, that means that there's only one real x-intercept. And now, without further ado, if b squared minus 4ac is negative, well, let's take an easy square root, like 9, but we'll make it negative 9. In other words, what number times itself is negative 9? Well, I'm just going to use my logic. Let's go with 3 squared. 3 squared is equal to 3 times 3. Well, that's positive 9. Well, fear not. How about negative 3? Well, negative 3 times negative 3 is also positive 9. In other words, if whether I have a positive times a positive or a negative times a negative, I'm still going to get a positive inside. That's not going to help me here because it's impossible. It's impossible to take a square root of a negative number. In the real number system. I should clarify, in the real number system. In Algebra 2, you'll learn what's called an imaginary number. Yes, there are imaginary numbers. So, if b squared minus 4ac is negative, that means it's impossible to take that square root. So if I were to draw these graphs, that means that it would be a happy face parabola above the x-axis or a sad face parabola below the x-axis. In other words, it's never ever going to cross y is equal to 0. So that means, without further ado, let me get this correct. Sorry about that. That means, come on, pen. No real x-ints. Sorry about that. So that means that there's no real x-ints if b squared minus 4ac is negative. Okay? So, without further ado, b squared minus 4ac is positive. That means that there's two real x-intercepts. B squared minus 4ac is 0. That means that there's only one solution, one real solution. And b squared minus 4ac is negative. That means that this problem is impossible to do. Okay? So let's, I'm looking at the clock right now, and I'm thinking, yeah, we should save these three problems for the next video. Okay? But for now, please take notes on this whole thing, because it's going to help you.